Hello, welcome back to Mrs. Torres' YouTube channel. Today, we are going to continue filling in the reasons part of proofs. So we're going to start with number 6 today. Number 6, we are given AB is congruent to DB. Let's mark it. Then we've got BC bisects AD. We've got to remember what bisects means. That means it splits it in the middle. So it makes two congruent segments there. All right, first we have our given. Our reason is given. Next, we have AC is congruent to DC. How do we know that? It's being bisect. So definition of bisector. Next, we've got BC is congruent to BC. Something is congruent to itself by the reflexive property. And we've got enough info to say the triangles are congruent by side, side, side. All right. Next one, we're looking at 7. Actually, we're going to skip 7. 7 is very similar to everything else we've done. Let's go to 8 instead. Number 8. So we've got AB, and then we have these two vertical lines here. We've got to remember this means parallel. So AB is parallel to ED. We can mark that on our diagram with little arrows like that. We're also being told AC equals EC. There we go. All right, first step, we just rewrite the given, and our reason is given. Next, we have angle A is congruent to angle E. All right. How might we know that? We have parallel lines, right? So we have parallel lines here. We can think of AE as a transversal. So let me redraw the picture. So here's AB, here's DE, and we can think of AE as a transversal like that. So up here is A, and here is E. These are the angles that we know are congruent. How do we know that? Alternate interior angles. These are alternate interior angles. So here's our alternate interior angles. We know when our lines are parallel that they're congruent. So we can say alternate interior angles are congruent. Next, we've got angle ACB, and this should say angle ECD. There's a little typo there. It should say ECD. So that's those middle angles there. Those are vertical angles. We should be very used to that by now. Vertical angles are congruent. And now it looks like we have enough info. Angle, side, angle. So whenever you're given lines are parallel, you want to think about corresponding angles, alternate interior angles, alternate exterior angles, all that good stuff to look for congruent angles. All right, let's look at number 9. Number 9 looks like this. Now, notice for number 9, we're given a very similar picture to number 8. However, we don't know that these lines are parallel, so we can't say that angle D and angle B are equal. Even though they are alternate interior angles, we don't know the lines are parallel, so we can't use that fact. All right, so we got AE bisects BD, and AE is congruent to, angle A is congruent to angle E. So we're given that those angles are equal this time. We don't need to use alternate interior angles. Next, DC is congruent to BC. So we've got that. How do we know that? Well, AE bisects, so we can say definition of bisector. And then we've got angle ACB is congruent to ECD. Vertical angles are congruent. And then our reason, we've got angle, angle, side. Oops, my light went off. Angle, angle, side. There we go. There we go. Sorry about that. All right. So that's number 9. Flip to the front of your packet. We're going to look at number 1, and that's the last one for today. Number 1. All right, so let's look at what we're given. TS is congruent to UT, here and here. And we've got TS is parallel to QU. So this time they are congruent and they're parallel. So our first reason is always just given. We just rewrite the given there. All right, next, excuse me, we're given angle T is congruent to angle Q. How do we know? Those are alternate interior angles. So this time we have parallel lines here, and you can think of TQ as your transversal, so those are alternate interior angles. Next, angle TRS is congruent to QRU. Vertical angles are congruent. And now we've got enough info to say these triangles are congruent by angle, angle, side. Alrighty, that's it for today. See you later.